we have three chunks here. The first being x squared. That would be added to the log of the fourth root of x minus 2 because they were multiplied. And then I would be subtracting log of x minus 2. Then exponents come out front. So this is 2 log of x plus, what is the fourth root of x minus 2 the same thing as? The 1/4 power. Just like 1/2 power is a square root. 1/3 power is a cube root. 1/4 is a fourth root. So this is actually x minus 2 to the 1/4. And I can bring 1/4 out front. So that becomes log of x minus 2 minus log of x minus 2. And that is your final answer. So the first thing I would do is I would condense these two together by multiplying. It's going to look something like this. X plus 2, x over x plus 2 times x minus 2 over x. Now how do we multiply fractions? Straight across the top. So basically this is just one big fraction, and we're multiplying the two things on top, and we're multiplying the two things on bottom. So x times x minus 2 and x plus 2 times x. But you're never actually going to distribute. You're never going to FOIL. You always want it to be factored, because then we can see stuff that cancels. So what happens when we have an x on top and an x on bottom? Yeah, so this x and this x cancel. So the first two logs condense down into log base 2 of x minus 2 over x plus 2. Minus the one that we haven't done anything yet with, log base 2 of x squared minus 4. Okay, now what does subtracting two logs tell me to do? Divide. So these are now going to be log base 2 of real big parenthesis. The first thing divided by the second thing. And for the sake of kind of seeing maybe what we're about to do, I'm going to write this over 1. So if you remember, a division divided by a division looks like awful, right? Like this looks like a hot mess. So let's think back to our basics. If I have 1/2 and it's divided by, let's say, I don't know, 2/3. What's another way of thinking about a division divided by a division? The division multiplied by the reciprocal of this the fraction on bottom, which would be 3/2. And that looks a lot better, okay? So I'm going to rewrite this as log base 2 of x minus 2 over x plus 2 times, now we're going to flip this upside down, 1 over x squared minus 4. So now we're back to kind of square one again. This is basically one big fraction. It's this times that and this times that. But x squared minus 2 can be factored. What is that? It's a difference of two squares, so that is x plus 2, x minus 2. So really, this is x minus 2 times 1, which is just x minus 2, all over x plus 2 times itself, which we can write as squared, times x minus 2. Yep. Anytime you have don't FOIL. Every year I have people FOIL all this out and get this big, long polynomial. Don't FOIL. We want it to be factored because then we can see the cancels. So this cancels with this. So my final answer is going to be log base 2 of 1 over x plus 2 squared. So today, now that it's the start of a new class, we're going to learn about something called the natural logarithm. ln. The natural logarithm. Yes. ln is just log base e. It's the exact same thing we've been learning about. The only difference is it's log base e. Instead of log base 7 or log base 10 or log base 41, it's log base e. E is just a number. Remember, e is about 2.7-ish. Okay? So another way of thinking about this is log base e of 4. It's the same thing. But your calculator actually has an ln button. So over here on the left side, ln of 4, and let's go ahead and get a decimal, round it to 4 places. 1.386, bless you. 1.3863 is what that comes out to.
It's right above star.
Now you could also, just to show you, if you go to the math menu and then scroll up, you remember how to get to the log base from last class? So log base, and then you could type in the number e, it's right above the division sign, second divided by. Log base e of 4 is the same thing, it's 1.3863. Math up. Same thing we did last class to get to log base. Okay, so for A, it says write an equivalent expression. What it means by that is write it as an exponential. So once again, this is NBC. Or if you're Skylar and think that's stupid, just think of it as left, right, middle. What is the base of natural log?
E.
It's E. E to the right side is 0.6931 equals X. So it's the exact same thing we did last class. The only difference is the base is E. And you could, it just says write an equivalent expression. It doesn't say solve necessarily. But at this point, you can now put that into your calculator and come up with the exact decimal that is, e to the 0.6931. Okay, now B wants us to go backwards. So I'm going to write it as log to start. So we're doing NBC backwards. Log base what? E. The base of the exponential is the base of the log. The base of the log is the base of the exponential. The base is always the base. But now the other two numbers are going to switch. So log base e of what? 5 equals the one in the middle, x. Left, right, middle. Now you will never, do what? That's what I was about to say. You will never see log base e on a standardized test. So if you're a junior, well, you're all juniors and seniors. If you're on the ACT, they're never going to write log base e. You need to know that that is natural log. So this here, natural log of 5 equals x is your answer. And usually, a test like the ACT won't give you decimals. So yes, natural log of 5, we could throw that into our calculator. ln of 5 is 1.609-ish. But usually a test like the ACT will keep it in this form. They'll just call it natural log of 5. That's prettier than that never-ending ugly decimal. Okay. Last thing for today, this is just reminding you of the special properties we learned last class. So if you think about it, this is actually e to the log base e of 7. And what happened last class when we had a base of an exponential and a log of the same base right next to each other? They cancel out. Just like multiplication cancels out division. Addition cancels out subtraction. Logs of the same base cancel out exponentials of the same base. So what's my answer here? 7.
But the log's not there.
It's natural log.
The log can pull out there.
Natural log is
in
log.
front of the e. Oh, that is.
This is a base of an exponential to a log of the same base. This is an exponential, right?
You don't use another log in front of the other e.
No. It's an exponential next to a log. And then here, basically, this is log base e of e to the 4x plus 3. So this is vice versa. If you have a log base of an exponential to the same base, those going to cancel. And my answer is just 4x plus 3. Obviously, I don't know what x is, so I just leave it in that form. Long story short, if you ever see an ln bumped up to an e, what are you going to do? Cancel out. Natural logs cancel out to the number e. Okay. So when we come into class next time, we're going to learn how to solve using this property, and then we're probably going to learn another lesson or two, and then you'll have a test on Thursday. Buckle up.